Hello everyone, this is Dilip. Welcome to my channel. I will be doing a series of videos on machine learning. These videos will help in advancing your machine learning career. I will mostly focus on the foundation so that every one of us can have a solid base on which you can build on later. Let's straight away get into the definition of machine learning first. So what is machine learning? Ultimately, everything is a computer program, and the way you program it differentiates between whether it's a machine learning program or a normal program. So if a computer program learns from experience C with respect to some class of task T and measured by a performance measure P, we call it a machine learning program. And there is a if condition where the performance of the program doing the task T measured by P, it should improve with experience E. So this is the definition given by Tom Mitchell in 1998. So let's take a example to explain this definition better. Spam email classification problem. As every one of you might have done in Gmail or any other email, we have an option to select an email and mark it as spam. And you might have observed Gmail does it automatically for some set of emails. So how it does is it does it by solving the spam email classification problem. Now let's go back to our definition and come back here. And classifying the email, whether it's a spam or not spam, this is the task T that the computer program has to do. And correct identification of email, it is measured by a performance measure P. So whether it is classified properly or not, it should not mark a spam as not spam and not spam as spam. So that is measured with performance measure P. And studying lots of emails. So this improves with experience. So there can be an email which is genuinely not spam and it is addressed to us. And it is marked as spam just because it has a word called heavy discount in that. So ultimately, the program can have better classification only if it sees a lot of emails. And after seeing a lot of emails, it should be able to better classify. Then only we call it a machine learning program. So studying lots of emails is experience E. So any machine learning program, like anything you take, if the goal of it is to perform some task T, and if it improves with experience, and we can measure the performance of the program, then we can say that the program is performing machine learning. Otherwise, it's not. So this is the way to identify whether a program is a machine learning program or not. Or same way, given a problem, we can see whether it has to be solved with machine learning or not by using this data. There are two main types of machine learning: supervised and unsupervised. So there are other types of machine learning like reinforcement learning and recommender systems, but these are not widely used and we'll ignore them for now, and we'll concentrate on supervised and unsupervised learning only. So let's straight away go to the supervised learning. So this is an example of supervised learning where we predict the cost of the house and we are given a set of data points based on the number of rooms. So you can see in the x-axis there's the number of rooms, and on y-axis you have the value of house divided by $1,000, so that we can better represent in tens, 20s the value of the house. There can be other parameters for determining the value of the house, like the location of the house, whether the house has 2 floors or 3 floors, whether the house is an apartment or an independent villa, but we will ignore all the other parameters. And for now, just for simplicity's sake, let's assume the number of rooms determines the value of the house. Okay. So here you can see there are lots of data points. So for supervised learning, we give it as input a set of data as well as the output values. So here our data we are inputting is the number of rooms and the output value is the value of the house. So we are giving the value of the house for a certain set of rooms we already have. So this is called a training data. Okay. So given our training data, the program will learn what to do with the training data. So based on that, it will form a set of rules. Either it can make a straight line on this. So for example, to fit this data, either it can, okay, let me, okay. So to fit this data, either it can draw a straight line through this data, okay, you can see now, either it can draw a straight line to fit this data, or it can draw a parabola to fit this data. Okay. So ultimately, the kind of rule it implements, it will determine my prediction. Okay. Now, let's say, for example, if your friend comes and he will ask, I have 7 rooms in my house. What will be the value of my house? So what is the value I can sell my house for? Now, if the program draws a straight line, sorry for this, this doesn't look straight, but assume it's a straight line. So if the program draws a straight line over the data for a 7-bedroom house, it will be roughly $30,000. But if the program draws a parabola on it, a 7-bedroom house can cost as much as $38,000. Okay, it can cost as much as this. So there are, so how the program draws a straight line or a parabola, there are a lot of details behind it. So we'll go into that in the later slides or later videos. So this is the machine learning problem with supervised learning. And in supervised learning, we have other types. So this is one type of supervised learning problem, and this is called reinforcement. This is called regression problem. The reason this is called a regression problem is because the output will be a real valued number. So for example, we cannot give a set of values like 10,000, 20,000, 30,000, and then we can say that depending on the number of rooms, that house value will be in this within the range. It can be anything. So it can be a continuous real number valued output, which we cannot predict. It can be between $10,000 to $20,000, any number between $20,000, $30,000, any number. So since we cannot predict it to be it can fall into a set of particular data. So we call it a regression problem. There is a second type of problem, which is most widely used in supervised learning or otherwise, which is called a classification problem. For example, we have to determine whether a person has a cancer or not. So there can be only 2 outputs for this, whether the person has cancer or the person doesn't have cancer. So it can be a 1 or 0. So this is called a classification problem. There can be multiple classes as well. Like we have to determine whether it is a type 1 cancer or type 2 cancer, type 3 cancer. So still, if it falls within a range, say for example, if you know that the output will fall within a range of 10 values, so or 20 values, so that's an example for classification problem, because we know the output will fall into a particular set. Okay, so these are the 2 main types of problems in supervised learning. Let's go to the next slide. So this is the example I was telling. So in a regression problem, given a set of data, we only have one class of data, and we'll draw a straight line like this to fit all the data on that straight line. Now, coming to the classification problem, what we do is, here also we'll try to fit a straight line, but we will make sure it will fall into one of the classes. Say for example, you have it has classified this data, and it has drawn a straight line on this. Now you ask it to predict a data point falling here. It can identify it as belonging to a circle class, and if you have a data point here, it can identify it to be belonging to a plus class. So it can classify data belonging to one of the classes. So that is why it is called a classification problem. In regression problem, we are not doing that. We can have the output can be any real numbered value. So if you have a data point here, it can be here. Its value will be this much. And if you have a data point here, we will draw access to it, and we will say its value will be this much. So like that. So that is the difference between classification and regression. So these are the only two types in the supervised learning. Okay, let's go to the next slide. Now, the second type of machine learning problem is unsupervised learning, where we don't give it any data. I'm sorry, we'll just give it the data, but we don't give it the outputs. So in supervised learning problem, in the earlier you might have remembered, we are giving it data as well as the value of the house. So we are giving it some set of outputs so that it can train itself. So here we are not giving it any set of output values so that it cannot train itself, and it doesn't know what is the correct result for a given set of data. So what it will do, it will try to cluster the data. So here you can see different types of documents are given, and these are scattered all across the data plane, and it can cluster all the nearby data together. How it will do it, we'll look at it in the later slide or videos. It will cluster the data in such a manner, it will become a meaningful cluster, which we can use it on the later purposes. A classic example of unsupervised learning is Google News. In Google News, you might have seen, given a story point, same storyline, you can see links from other websites as well, not only from one news website, but you can see from other news websites. How it will do is it solves the clustering problem. So that is an example of unsupervised learning. And there is the last type, reinforcement learning, and others as well, but these are not important. So let me give a brief on the reinforcement learning. So this is otherwise can be referred as carrot stick method. So where if a program behaves in one manner, we encourage it, and if the program behaves in the wrong manner, we discourage it. So this is a risk and reward system. So based on the rewards, increase of the rewards, it will try to align itself into the more rewarding way and reduce aligning itself to the riskier way. So that is called reinforcement learning. Mostly in robotics, this is widely used, but it's not as widely used as supervised or unsupervised learning models. So that's it. In the next video, we'll start talking about supervised learning. I hope every one of you got a good understanding of machine learning basic definitions. Thank you for listening.